Alright, I got several papers I want to hand out to you. And first one. Oh wait, I already handed these up to you, didn't I?
Pretty sure. Yeah, we got
Okay.
Yeah, we got Yeah, we got
Never mind. I know I handed out monatomic and polyatomic ions, but I hand out this one here. No? Okay. This is kind of an overview over for this entire chapter. Okay. And also, I'm going to give you this other periodic table. This one does not have as much detail to it, and it's meant to give you some space here to write some additional information. So when we start getting into charges of the different areas of the periodic table, just where you put that information down. Okay, so now, I'm not sure how far did I get last time here. For the monatomic ions. Okay.
Okay. Let's see if I can get this here. Did I go over this part here about what to know, what not to know?
Yes.
Okay. So you have to know the negative ions here, and then these three columns over here. Okay. So this is the one where if I give you one, you have to give me the other two. I'm hoping to have the quiz on this before we go on Thanksgiving break.
Right.
So like next week.
Yeah.
Okay. Possibly by the end of today, you'll have probably about 3/4 of this stuff already figured out. Okay. There is a pattern to this. Once you understand that pattern, it'll make things a lot easier for you.
Okay. So, and then, fingers crossed, I'm hoping to have the quiz for the polyatomic ions, before we go on Christmas break. So that's what I'm hoping for. And then, fun times will be had by all. Alright, so, alright, quick little review. What is the overall charge of an atom? Neutral, okay. And if you have where the number of protons and the number of electrons are not equal to each other, what do you call that? That's an ion, okay. Now you have positive ions and they're negative ions. What do you call a positive ion? Cation, okay. What's a negative ion? It's an anion, okay. If it's a cation, it has a positive charge to it. Let's see here. Did it gain or did it lose electrons? Okay, it'll lose electrons. Because you're losing negatives, it makes it more positive. And then a little bit, we'll start getting into the negative ions, where it's going to start gaining electrons. What is the charge of group 1? Positive 1. That means that it lost 1 electron. What's the charge of group 2? Positive 2. What's the charge of group 13? Positive 3. And then, what's the charge 3 through 12?
1 through 4.
1 through 4, but what's the most common charge?
2.
Positive 2. The most common charge is positive 2. Now we're going to go into a little bit more details about that here up to bit. All right, so for groups 1, 2, and 13, how do you name them? 1, 2, and 13, how do you name those ions?
Their name and then a Roman numeral and
You just say its element name and then ion. Okay. So for example, potassium is in group 1. Potassium will take on a positive 1 charge, so you just simply call it a potassium ion. That's it. Okay. Magnesium is in group 2, so it's going to have a positive 2 charge, so you just call it a magnesium ion. That's it, okay? Aluminum is positive 3, you call that aluminum ion, because it's in group 13, it's a positive 3 charge. Now, the problem is that when you start getting into elements where you have, let's see if I can get this here. When you start getting into elements where they can have more than one charge. So for example, let me get rid of this here. So if I have Fe positive 2 and Fe positive 3, this should be called an iron ion. And this should also be called an iron ion. Okay? See, they're showing up there, okay? But the problem is, you cannot differentiate between the two. Remember that story I was telling you about George Foreman? Names his kids all George. I think they all have the same first, middle, and last name. Okay? So, you need some way to be able to differentiate one from the other one. Now, the old way of doing this here is that if you have the lower of the two charges here, you either end it with OUS. If it has a higher charge, you end it with IC. Okay, so so what happens here is iron used to be called ferrum, so it goes back to its original name. So they call this one here a ferrous ion. And this will be the higher of the two charges. This is called a ferric ion. All right, now, the problem is that iron can have more than one charge. It can have more than two charges. It can sometimes have positive 4. You can even have like a positive 6. There's even positive 1, positive 5. So the problem is, we just ran out of ways of naming this. So the other way of doing this is kind of what they refer to as the stock system, is where you use the Roman numeral for it. And so what you're going to do is whatever positive charge it has, that's what you use as a Roman numeral inside of a set of parentheses. I went over this yesterday, correct? Okay. So, like copper, if it has a positive 1, it's called a copper 1 ion. If it has a positive 2, then it's called a copper 2 ion. And the same thing with this over here, is that instead of calling this, you can't simply call it an iron ion here, so you call it ferrous or ferric, or using the new system, you could also call this what? If you go back to, you say its element name, what's Fe? Iron. Iron what?
2.
And then use Roman numeral 2, ion. This will be called, this is I. Ion. And then the next one will be called
Iron 4.
iron 4 ion.
1 IV.
IV, yep. Ion. And the last one will be called
Iron 6.
Or
VI.
VI, ion. Okay? This is kind of a little bit easier because it doesn't matter what charge you have. That is the, all you have to do is put whatever positive charge it has as a Roman numeral inside a set of parentheses. Okay? Now, take a look at your monatomic ion paper. Take a look at this. Okay, the one with the 3 columns to it. Okay? Now, a few things to point out to you. Look at the part where it has the 3 columns. Now, if you notice, you have stuff like cuprous and cupric, ferrous and ferric, mercurous and mercuric, plumbus and plumbic, stannous and stannic, chromis and chromic, manganese, manganic, cobaltus, cobaltic. Everyone knows that? Okay? And again, if you notice, all the ones with OUS is a lower charge, all the ones with IC has a higher of the 2 charges, right? And then all the ones with the Roman numerals to them, the Roman numerals match up with the charges, like copper 1, positive 1, copper 2 has a positive 2, iron 2 has a positive 2, iron 3 has a positive 3, etc. Someone notice anything unusual? take a look at this. And there's actually one of them that actually has two kind of unusual things.
Mercury is plus 2, but we also has one.
There you go. Also, if you look at, especially with the classical name, all of those went by their kind of their original names for the metals, like copper used to be called cuprum, iron used to be called ferrum. Mercury, it just remained as mercury. Mercury used to be called hagna. So technically it should be called Hagnus and Hagnic. Why they did not do that, I don't know. But that is, but they end up leaving it as mercury. But what's the other thing that you noticed?
It's +2 +2.
Yeah.
Mm-hmm.
Not
Okay.
bigger than one.
So, one thing that's different about it. Mercury is a weird element. It's a weird ion. You have Hg2 positive 2, and there's also an Hg positive 2. Okay? And, so one note the subscript 2 mean.
That means there's 2 mercuries.
There's 2 mercuries. This is actually Hg positive 1, Hg positive 1. 2 of those.
So it just makes it shorten it up.
Mercury is weird where it likes to have a positive 2 charge. And if it does not have a positive 2 charge, it'll combine with another mercury to give itself a positive 2 charge. So if it has a positive 1, it'll team up with another one, kind of pull the resources together to make a positive 2 charge. And that's really the only one that's kind of unusual. So that's about really, when it comes to memorization, that's one of the main ones you have to kind of memorize, is that there is a pattern for everything else except for this one. Okay? And that's the reason why this one is referred to as mercury 1, because technically it is 2 mercury 1 ions. And this one here is actually a mercury 2. It's a mercury 2 ion, or mercurous and mercuric. You might want to make a little note in your paper here. Hg2 positive 2 is technically an Hg positive 1, Hg positive 1. So you might want to make a little note of that in your ion papers.
Which one? The one that has all the names on them?
Yeah, the one with the 3 columns to it. Okay. You guys good so far? Okay. So now, let's get into the nonmetals. So, for nonmetals, so metals have a tendency of losing electrons, nonmetals have a tendency of gaining electrons. And so, for example, if you look at group 18, starting with group 18 elements here. First of all, they don't lose and they don't gain any electrons. And because the electrons don't move, are not being lost or gained, they don't do anything. And that's one reason why noble gases has that characteristic where they don't react with anything. So typically, you're going to have no charge to those. Now, group 17, they have a tendency of gaining 1 electron. And when they gain 1 electron here, you have to keep in mind, an atom is neutral. Also, you now have 1 extra electron to it, so, which has a -1 charge, so you're gaining more negatives. So it becomes a -1 charge. A lot of times when people see a -1, they think of subtracting 1. You're gaining negatives, or you're losing negatives. So, for example, if you look at this, what element would this be? Might be easier to by counting the electrons.
Oxygen.
Count oxygen.
Fluorine.
Fluorine. Yeah,
I
that's
thought
fluorine.
Definitely not.
Okay. So, this is a fluorine atom. And the reason why it's fluorine atom is because you have 9 protons and 9 electrons. Who determines the identity? Protons. So as long as you have 9 protons, this is always fluorine. And this has no charge to it. Technically, this is a fluorine with a superscript 0 to it, but that's kind of redundant. But fluorine has a tendency of picking up one more electron. And if it picks up one more electron, it still has 9 protons, but now you have 10 electrons. And so, in doing so, you now have a -1 charge. So you write that -1 charge up here. So you write that as an F-1. It simply means it's a fluorine with 1 extra electron to it. Does that make sense? Okay, so it has a -1 charge. Now, if you go to group 16 elements, they have a tendency of gaining 2 electrons. And so they take on 2 extra electrons, they're gonna have a -2 charge. So what element would this be? Yeah, this is oxygen, okay? There,
I
one
can't
up there.
count.
My bad.
Nice one, Tommy.
Like counting the protons. It's like,
It's hard to tell, they're all kind of stuck on top of each other. So you have 8 protons, you have 8 electrons in there. So right now, this is an oxygen atom. But then oxygen will pick up 1 more electron. But it doesn't stop there, it can also pick up another electron, eventually. And so now, we're up to 10 electrons. So it's still oxygen because it has 8 protons, but you now have 2 extra electrons to it, so it gives it a -2 charge, so you write it as a O -2. Simply means it's an oxygen with 2 extra electrons to it. And then group 15 will typically gain 3 electrons, so that takes on a -3. I don't have it up here on the slide, but also group 14 will typically gain 4 electrons, making it a -4. Now, yesterday, did I go over about like when an atom is losing electrons, what does it look like? What element is it becoming like?
No.
No? Okay. Actually, this would be a good time to do that here. So, if you look back here in the back, come for the ride. Can you guys see? Move this off the side just a little bit here. Okay. Now, there is a reason why these elements tend to gain or lose electrons the way that they are here. Key thing is, if you remember these elements right here, group 18, they don't do anything. Okay, they don't gain and they don't lose. They're basically, these are the most stable of all the elements. Now, group 1 has a tendency of doing what?
one.
Not gain, lose 1 electron. So when they lose 1 electron, they become positive or negative? Positive, because they're losing more negatives, it makes it more positive. So for example, lithium, right now it has 3 electrons to it. It has 3 protons, 3 electrons. If you lose 1 electron, how many electrons would you have? 2. Which is the same thing as helium. Beryllium has 4 electrons. It's in group 2. How many electrons do these lose? 2. If you lose 2 electrons from 4, you have helium, 2. Aluminum, boron, has 5. It's in the column where it becomes a positive 3 charge. It loses 3 electrons. That's 5, you lose 3, you end up with helium, 2. Calcium, in group 2, it will lose 2 electrons, it has 20. If you lose 2, you end up with 18. Argon. Now if you have sodium, which has 11, you lose 1, it becomes 10. Neon. What's that? It'll start looking like a noble gas. I don't know if you guys remember, I know how old you guys were, during one of the royal weddings here, was it King Charles? Who was he? It's one of the most recent royal weddings here. Anyway, it was heavily televised, and she wore this nice dress and everything else like that. And after she had her wedding, every bride afterwards for several years wanted to have a dress that looked just like hers. And a lot of times here, the royalty is, those are typically people where people try to aspire to be kind of like them. Or, if you think of like some of the some of the famous people, they wear some type of clothing, everyone else wants to be dressed up just like them, okay? That's what the noble guests are kinda like. They're kinda like the elites of the periodic table. All the other elements wanna kinda look like them in their own sort of way. And so what happens with these elements here is they're kind of like dressing up. They're not changing the inner core, the number of protons, but they're changing the outer appearance, the electrons, so it looks like a noble gas. Okay? And so typically for these metals, they will lose electrons to look like a noble gas. Now, we go to the non-metals. They're over here. Everything group 17, what charge is group 17? -1. How far away are all of these from being a noble gas? Only one away. They only have to gain one electron to look like a noble gas. If you look at the non-metals in group 16, they're 2 away from being a noble gas. So all they have to do is gain 2 more electrons to look like a noble gas. Same thing with group 15, like nitrogen and phosphorus, they only have to gain 3 electrons. Carbon's kind of sitting in a unique position because it's actually halfway in between those two. It can either gain 4 electrons or it can even lose 4 electrons to look like helium. And that's one thing that's kind of unique about carbon is that it sits right in the middle. It can either gain 4 or it can lose 4 electrons. And if carbon did not have that ability here, there would be a whole branch of chemistry that didn't exist. That's organic chemistry. And that is also kind of the building block of even biochemistry. So like the chemistry within living things here. But basically, for most of the elements, they'll either gain or lose electrons, so they kind of look like a noble gas. Okay, now, let's come back over here. Alright, so now, let's go through and naming the nonmetals. Naming the nonmetals, there's a little bit of extra work you have to figure out here, okay? It's real difficult. The way you do this is you drop the ending and you add "ide." That's it. Okay? Real tough, isn't it?
I was actually gonna be harder.
I didn't.
So for example, fluorine. Fluorine's in group 17.
Fluoride.
Fluorine becomes, and it has, what charge is it? -1. So fluorine becomes fluoride. Nitrogen, what charge will nitrogen take on? Group 15. How far away is it from being a noble gas?
3.
3. It'll take on a -3 charge. So N-3 is called nitride. Very good.
I like that name.
You guys heard fluoride before, like fluoride in your toothpaste. You don't have fluorine in your toothpaste, you have fluoride in your toothpaste. It's not F, it's F with a -1 charge to it.
That's the stuff they like put on your teeth at the.
Yep. Yep. So, let's go back here again. We're taking a lot of trips today. Alright, so now. So, using this newfound knowledge. Alright, look back here, please. Group 17, what charge is group 17? -1. So to name it, F -1 is fluoride. Chlorine becomes bromine, iodine, iodide, acetine, acetide. Don't worry about this one here. It would probably still be the same thing, whatever 117 is. Now, non-metals in group 18, basically oxygen and sulfur. What charge do these have? -2. Oxygen becomes, what is it? Oxide. Sulfur? Sulfide. Non-metals in group 15, which is basically nitrogen and phosphorus. What charge do these have? -3. So nitrogen becomes nitride. Phosphorus? Phosphide. Alright, now, carbon. If it takes on a -4 charge, it becomes carbide. You ever heard like tungsten carbide, like cutting tools? Okay, that's the carbide in tungsten carbide. Now, it's rare, but it does happen. hydrogen will sometimes will take on a -1 charge. So if it becomes a -1 charge, it follows the same rules as these over here. So hydrogen becomes hydride. Now, most often hydrogen will lose 1 electron, and so it just becomes either hydrogen ion or hydronium. But if it takes a -1 charge, then it follows these rules over here. So for the negative charges, you drop the ending and you add "ide" to its name. Okay, now, take a look at your monatomic ion paper. All right, so, guess what you just did? Take a look at this side right here. We had the negative charges right here. See this part right here?
We just learned all.
You just learned all of this. Real difficult, wasn't it?
Can we take the test?
Not yet, because you haven't figured it out just yet.
Okay.
Okay? I'm gonna give you some information so you can start figuring this stuff out here, okay? But yeah, right now, for your negative ions, so remember for the quiz, you need to know the negative ions and then these 3 columns here. Right now, you should be able to do this part right here. Now, I will tell you this, basically from here on out, you guys will have a periodic table in front of you. It will not be the ones that you've marked together here, it'll just be like the ones, like the normal ones I've been handing out to you guys here. So you will be able to use that as an aid, all right? But right now, you have all these right here. So now, we need to start working on these over here, okay? Now, on that periodic table I gave to you, kind of that blank periodic table, what I'd like for you to do is copy this down. You can see here. So on this kind of blank periodic table here, okay? I took out the numbers, like the mass numbers, just so it saves you a little bit of space. What I'd like for you to do is all this is group 1. All these are group 2. 3 through 12 is mostly 2, but can range from 1 through 4. Okay? Group 13 is +3. Now, look up here for a second. Don't get ahead of me here. The pink ones here are 2 and 4. Now, because this part right here, which is silicon, don't put 2 and 4 in silicon. You might be better to put those numbers inside the blocks. Okay? And then same thing for 2 and 5, is these 2 elements down here. Ignore these, the ones that are shaded in black, ignore those for now. And then these are mostly +3, but can range from 1 through 6. So I'll give you a couple minutes here, put these in. Also, if you notice, this periodic table does not have the entire 7th period down here, so it's a little bit confusing for you, let me know. All right, so I'll give you a couple minutes here to work on that. In a little bit, we'll put the negative charges up there.
So you said put like +2, +4 in each
Mhm.
of those pink.
Yeah, so inside each one of those boxes, put down 2 and 4. So carbon will be 2 and 4. Skip over silicon. Then you have germanium, tin, and lead. All these, germanium, tin, and lead are 2 and 4. And then SB and BI, antimony and bismuth, are 2 and 5. Someone knows that any patterns to this. It's not a perfect pattern, but there is a little bit of a pattern to it.
Goes 1, 2, 3, 4, 5.
Mhm.
Yeah, so further right you go, the
1, 2, basically 2, 3, 4, 5. Okay, or, yeah, you have like 2 and 4, 2 and 5, but basically it's 1, 2, 3, 4, 5. If you can remember that pattern, that will help you out quite a bit. Now, these are just for the metals. That one good? Okay. For the non-metals, I'm gonna put these down. So, 18, group 18 is 0, 17 is -1, 16 is -2, 15, now for 15 here, that's nitrogen, phosphorus, and arsenic. They have a -3. Group 14 is carbon and silicon, these have a -4. Now if you notice, what's unique about carbon?
it has +2, +4, and -4.
Mm-hmm. Yep. Remember, carbon kind of sits in a unique position where it can either go positive or it can go negative. Now, do you see a pattern to this?
Mm-hmm.
It's a lot easier to see on this one here. Now, if you remember when you were drawing up the periodic table and I was showing you some like the weird three-dimensional ones here, if you look at this right here, this can, if you kind of look at the periodic table being almost like this, if I take this and roll it up, think of a number line. This is kind of like a number line here. Where this is like the center part of your number line, you have your positive numbers on one side, you have your negative values on the other side. That's kind of what we have here.
That puts like the noble gas right in the middle.
Noble gases are right there as a 0 point.
That goes 1,
And then you go, your negatives one way and you go positives the other way. Now, the only thing is, it wraps around onto itself. But basically, it's kind of like a number line. Now, in this situation here, no, actually, you know, so you have your negative on the left, positives on the right. If you kind of look at this way here. Okay. All right, any questions on that part? Okay. Now, the other thing I want you to do on your periodic table is we're going to put the names on here, kind of the rules for naming them. Now, this is one reason why on this periodic table, you can do whichever one you feel is best here. You can either use this side and then like use the other side for the names, or if you want to put everything on one side, that's up to you. Okay? So do whatever is easiest for you. Okay, so let me draw this out. Get that on there. Yep, basically. Okay. So groups 1, 2, and elements in group 13. These right here. The way you name these is you say the element and then ion. Element and ion. Element and ion. Now, if you remember, you have that kind of zigzag thing down through here, okay? You have your nonmetals over here. Your nonmetals, you just go the ending is IDE. IDE. Now, for these through here, and also the metals in this section here, and even the metals in this section here, because they have more than one charge, this is where they have multiple systems for naming them. The old system is where you have, if you have lower charge, it ends in OUS. Higher charge ends in IC. The new system is where you have the element name, and then parentheses is charge. I'm using RN as a Roman numeral, short for Roman numeral. So a set of parentheses. And you have the same thing down here. So the old system is lower charge, is OUS, higher charge is IC. New system, you see it's element name, parentheses, the charge as a Roman numeral, RN, or Roman numeral, inside a set of parentheses. So it's for the metals that's not in group 13, in the D block here, I'm sorry, in the P block, the section down here, for these metals down here, and also the metals in 3 through 12 through here. Good with that?
So zoom into a little bit. Oh. Ground shaking.
Any questions on that so far? No? Okay. What do we have here? I tell you what, tomorrow I'm going to show you how to figure out, if you look at this, how do you figure out if it's a positive 1, positive 2, or if it's a positive 2 and positive 3, or positive 2 and positive 4. So I'm going to show you how do you go about figuring that out. So if you can remember a few simple rules, that'll help you figure out what two charges can it possibly have. Okay? So we'll go over that tomorrow.